Meet Maya. She's working on a science fair project about her school's recycling program, and she just found two graphs online about the same data, but they look completely different. One makes recycling look like it's skyrocketing, the other, barely a blip. How is that even possible? Today, we're going to uncover the sneaky tricks people use to make graphs mislead you and teach you how to catch them every single time. So, what exactly is a misleading graph? Here's the thing. Graphs are supposed to help us understand data quickly and clearly. But sometimes, the way a graph is designed, on purpose or by accident, makes the data tell a completely wrong story. The numbers might be totally accurate, but the picture they paint is totally fake. This happens in news articles, advertisements, and even textbooks. Maya had no idea this was even a thing. But now that she knows to look, she's going to question every graph she sees. And so should you. The most common graph trick is called a truncated y-axis, and it's sneaky good. Instead of starting the y-axis at 0, someone starts it at a higher number, like 95 or 990. Suddenly, a tiny difference between two bars looks absolutely massive. Imagine a graph showing test scores where everyone scored between 95 and 100. If the y-axis starts at 94, those small differences look like a canyon. But if the y-axis starts at 0, you'd barely see the difference. Maya spotted this exact trick in one of her recycling graphs. The recycling rate went from 48% to 52%, but the graph made it look like it tripled. Here's another sneaky one, messing with the scale and intervals on an axis. A fair graph uses equal spacing, 0, 10, 20, 30. But a misleading graph might jump like this, 0, 1, 5, 50, 500. That uneven spacing can make a slow, gradual trend look like a sudden explosion, or make a huge jump look totally normal. It's like if someone measured your height in inches for the first 3 years, then switched to feet. Your growth chart would look wild. Ready for the next level? There's another trick Maya found that's even more subtle. Now this one is really sneaky, cherry-picking data. Imagine a company selling lemonade. Their sales dipped for 2 years, then jumped one summer. If they only show you that one good summer on a graph, it looks amazing. But show the full 5 years? Not so impressive. People cherry-pick by choosing start and end dates that make their data look better, or by leaving out data points that disagree with their story. Maya found that the graph making recycling look terrible was only showing data from the 2 worst months of the entire year. Always ask yourself, what time period is this covering, and what might be missing? One more trick before we start practicing, misleading pictographs. Pictographs use pictures or icons to represent data, but here's the trap. If something doubles in value and someone doubles the icon's height and width, the icon actually looks 4 times bigger, not twice as big. That's because area equals length times width. Double both, and area quadruples. The same thing happens with 3D bar charts. The visual volume grows way faster than the actual data. Maya saw this with a pictograph comparing 2 schools' lunch sales. One school sold twice as many lunches, but the icon looked 8 times bigger. That's just not fair. Let's work through an example just like Maya would. Here's a bar graph showing daily sales at a school store. Monday, $98, Tuesday, $99, Wednesday, $100. The graph's y-axis starts at $97 and goes up to $101. Looking at the bars, Wednesday looks like it earned triple what Monday earned. Huge difference, right? But wait, let's check the axis. It starts at 97, not 0. The actual difference between 98 and 100 is just $2. On an honest graph starting at 0, all 3 bars would be almost exactly the same height. Maya caught this one right away. Can you spot the truncated axis every time now? Here's another one for Maya, and for you. Look at this graph's y-axis. 0, then 1, then 10, then 100, then 1,000. Each jump is 10 times bigger than the last. A data point at 100 and a data point at 1,000, on this scale, they look close together. but the actual difference is 900 units. Now look at the same data on an evenly spaced axis. 0, 200, 400, 600, 800, 1000. Suddenly, that gap between 100 and 1000 is obvious and huge. The rule to remember: every step on the axis must be the same size. If the steps are different sizes, the graph is lying to your eyes. Maya's working on her science fair project and finds a graph titled "Recycling is Growing Fast." It shows data from 2022 to 2023, and the line shoots straight up. Impressive. But then she finds the full data set going back to 2018. From 2018 to 2021, recycling rates actually dropped for 3 straight years. Then 2022 and 2023 had a small recovery. The cherry-picked graph shows only the recovery, leaving out the 3 bad years completely. So the question you should always ask: what is the full time range of this data, and why did they choose to start here? That question alone can expose a lot of sneaky graphs. Let's tackle the pictograph trick with Maya. A pictograph shows School A sold 100 lunches, and School B sold 200 lunches, exactly twice as many. The designer doubled both the height and the width of School B's lunch tray icon to make it look bigger. But let's do the math. Area equals height times width. If both doubled, 2 times 2 equals 4. So School B's icon is 4 times the area of School A's, even though the school only sold twice as many lunches. That's 2 times too much visual impact. When you see pictographs, always check: did they only scale one dimension, or did they scale both? If both scaled, the picture is exaggerating. Maya now has a superpower. She knows exactly what to look for. And guess what? So do you. Here's your 4-question graph checklist. 1. Does the y-axis start at 0? If not, those differences might be fake. 2. Are the scale intervals equal? Uneven jumps distort trends. 3. Is the full time range shown? Missing years can hide the real story. 4. Are icon sizes proportional? Doubled icons can be 4 times the area. Every time you see a graph in a news article, an advertisement, or even your textbook, run through this checklist. You'll be amazed how many graphs don't pass the test. Let's put it all together with Maya's science fair project. She has 3 data points: January at 48%, June at 49%, and December at 52%. A misleading graph shows only December versus January, with a y-axis starting at 47%. The bar for December looks nearly 3 times taller than January's bar. But let's build the honest version. Y-axis starts at 0. All 3 months are shown. Now, January's bar at 48 and December's bar at 52 look almost the same height, because a 4 percentage point difference out of 100 is actually pretty small. Maya uses the honest graph for her science fair project and earns extra credit for catching the misleading version. That's our girl. Remember when Maya was staring at 2 graphs about the same data, totally confused about why they looked so different? Now she, and you, know exactly why. Graphs can truncate the y-axis to make small differences look huge. They can use uneven scales to fake explosive trends. They can cherry-pick time periods to hide bad data. And they can use oversized icons that exaggerate visually. But now you have your checklist, and you're a certified data detective. The next time you see a graph, in the news, in a commercial, anywhere, you'll know exactly what questions to ask. Math isn't just numbers. It's a superpower for seeing the truth.